Hello, I'm miles tails per hour. You have arrived at the final part now. Let's get started with centrifugal and centripetal force. The centrifugal force is an inertial force that appears to act on all objects when viewed in a rotating frame of reference. Suppose a planet Earth is orbiting around the Sun. Assume that it is in circular orbit, but actually is elliptical. In case of centrifugal force, it is directed away from an axis passing through the coordinate system's origin and parallel to the axis of rotation. On the other hand, in case of centripetal force, which is towards the axis, when we balance centrifugal and centripetal force, the planet Earth would stay in the orbit. If the centrifugal force and centripetal force is not properly balanced, the planet Earth will fly off the orbit or goes into the large planet to collide, resulting in a huge devastation of a planet. I have an idea. Watch Knuckles flying off, in spinning blades of death, as soon as Sonic turned on hyper mode. Blades spinning faster and faster. Now, he'll fly off. Just like for another example, in a laundry room, you might have seen clothes sticking together in the walls of drum and washing machine during spin cycle. Well, that was fun. Now, note that the centrifugal force formula is mass times square velocity divided by radius. Same way, you'll get in terms of newtons. If the radius decreases, the centrifugal force increases, and vice versa. For example, if m is 1 kilogram, velocity be 2 meters per second and the radius be 4 meters, we get a centrifugal force of 1 newton. And last but not least, the Coriolis force. Coriolis force is an inertial or fictitious force that acts on objects that are in motion within a frame of reference that rotates with respect to an inertial frame. The planet Earth rotates 24 hours a day, that you might need to convert to seconds. Any object flies or travels along the latitude. This must be given sign of phi. The object goes towards either north or south direction. The formula is therefore 2 times mass, velocity, and angular velocity omega, times sine phi. There is only one possible value of rotation of an Earth, 2 pi divided by 24 hours 60 minutes 60 seconds. Or you must mean 7.27 times 10 to the 5th negative exponent. Keep in mind, if an object is at the poles of an Earth, say sine 90 degrees, we get maximum Coriolis force. If it's at the equator, then its Coriolis force is 0. That's all for the topic. Like, comment, and subscribe now.